I have a joint distribution problem, therefore I'm going to draw a picture. I know I sort of sound like a broken record on this point, but I just find it really important and useful in these problems. Now we're told that y is less than x, so I'll draw the line y equals x. I want to be below that picture. X ranges from 0 to 5, so I have this little triangle here. Now, because I've drawn this picture 5,000 times, it takes me about 2 seconds to do it if I'm actually doing it myself under exam circumstances. So it doesn't cost me any time, but it makes me much more likely to get the question right because I'm making sure that I'm actually looking at the right region, and I just find that I'm less likely to make a stupid mistake. Now, I want the expected value of x conditioned on y being equal to 3. So I want the expected value of x conditioned that I'm on that particular strip right there. So what's the first thing I want to find? Well, one thing I could find is just what is the conditional density of x? What's the density of x if I'm conditioning on y being equal to 3? Well, by the definition of conditional density, it's going to be the joint density where I plug in 3 for y, is the probability of both occurring, divided by the probability of y being equal to 3. It's not really probability, densities aren't really probabilities, but that's the way I remember this formula. So what do I divide by? I divide by all possible values of x that correspond to y being 3. This is where my picture is handy. Y is less than x, or in other words, x is greater than y. So the ranges of possible values of x range from y to 5. And so I'll integrate from y to 5 my joint density with respect to x. That's basically just a normalizing constant to make what I have on the right-hand side equal to a probability function. Sorry, I mean to say equal to a probability density function, right? Because I need my whole thing integrated over everything to be equal to 1. And so my denominator is a renormalizing constant that will make that work. So what do I have in the numerator? Well, I'm told my joint density is 1 over 5x. So that my numerator is 1 over 5x. What's my denominator? It's going to be the integral from 3 to 5. So that should have been 3 here, and not y as my lower limit, because we know the value of y. We know it's equal to 3. So it's integral equal to the integral from 3 to 5 of 1 over 5x integrated with respect to x. And so our numerator is just 1 over 5x. Actually, the 5's cancel out. So my numerator is 1 over x. My denominator is the integral of 1 over x from 3 to 5. So that's going to be the logarithm of 5 minus the logarithm of 3. Because basically I canceled out that 5 with that 5 that we had downstairs. So what does that give me for my density, my conditional density of x? It means that my conditional density of x is going to be basically 1.96 divided by x. What therefore is my conditional expectation of x? Well, the expectation of x, given that y is equal to 3, that's going to be the integral from 3 to 5 over all possible values of x given the information that we have. So I'm not going from 0 to 5 because I know y is 3 and x must be therefore at least 3. So I'm going from 1 to 5 of 1.96 over x, my density, times another factor of x because I want the expectation of x, integrated dx. In other words, the x's cancel out, and I just get 2 times my 1.96 number, and I end up with 3.92. So I'm going to get here answer choice B.